Equipment auction data is a mess. The same Caterpillar D6 bulldozer sells 3 times across different states, and each auction house records the model slightly differently. 580 Super L in one record, 580 SL in another. Same machine, totally different strings. This is the core challenge of entity resolution in the real world. Identical things look different on paper. And when you're working with 401,125 auction records across 53 columns, getting it wrong is expensive. We ran GoldenMatch, an open-source deduplication library, on the Kaggle Bulldozer Bluebook dataset to see how far we could push automated entity resolution. The result, 384,650 records matched into 27,937 duplicate clusters, and the system learned the optimal matching threshold from just 200 pairs. Total LLM cost? 1 cent. But getting there required fixing some real problems first. Our first attempt used GoldenMatch's zero config mode. 1 line of code. Let the system figure it out. The result was 0 matches. The auto-configuration had misclassified 3 critical columns. The sales ID field, a 7-digit integer, was flagged as a phone number. The sale price field, a 5-digit round number, was classified as a zip code. And the model description field, the single most important column for matching equipment, was dropped entirely because it appeared after the fuzzy field limit. Version 1.2.6 fixed all 3 issues. ID patterns are now checked first. Price and cost fields are correctly identified as numeric. And field ranking is now based on utility, cardinality times completeness times string length. So high information fields like model descriptions naturally rise to the top. With the correct configuration in place, GoldenMatch ran 3 blocking passes to group candidate pairs, but 90+ of those blocks were oversized, some containing over 60,000 records. Processing them directly would mean billions of pair comparisons. Skipping them entirely means missing real duplicates. The solution is ANN hybrid blocking. When a block is too large, GoldenMatch extracts the unique text values, embeds them using a vector model, and uses approximate nearest neighbor search to group similar descriptions into subblocks. 15 oversized blocks were recovered into 363 subblocks, matching 949 additional records that string blocking had missed entirely. Embedding 187 unique texts took 4 seconds. Then comes the calibration step. After fuzzy scoring, 135,000 borderline pairs sat in the 0.85 to 0.95 score range, too uncertain to accept or reject automatically. The old approach would score every single one via the LLM. That's over 1,800 API calls and $50. Iterative calibration takes a smarter approach. In round 1, 100 pairs are sampled across the score range and sent to GPT-4o Mini. The result revealed a clear boundary at 0.946. A second round of 100 pairs near that boundary confirmed a threshold of 0.947. Converged, done. That threshold was then applied to all 135,000 candidates, promoting 1,533 to match status and keeping the rest where they belonged. 2 API calls, 200 pairs, 42 seconds. The final numbers tell the story. 384,650 records matched, 27,937 duplicate clusters identified, and 87.7% of clusters with confidence above 0.4. Compare that to a simpler string-only run, which produced a threshold that was far too permissive and promoted over 8 million false pairs. The key insight is that you don't need to ask the LLM about every borderline case. You just need to learn where the boundary is. GoldenMatch version 1.2.6 is live on PyPI. The full example is in the repository, and the LLM calibration and blocking strategies are documented in the guides. If you're working with messy real-world data at scale, it's worth a look.